Hi, welcome back. So in the previous video, what I did was just take some of these particle sims we made and add the attributes that we need to make them renderable, pretty much, and double check that transforming them back into the animated position was working. So that's fine, that all worked well. And then I have this idea that I have on the side for later as well, which is our sci-fi idea. So next we'll be adding basically trying a bunch of SOP tricks to add extra layers to our main effect here. But before we do that, I just want to do a quick detour and add our projectiles. Just by adding the projectile, it will be a bit more easy to visualize. So if I can at least do some flip books that include the tracer that comes in and hits the shield, I think it will help to make sure that our impacts feel strong enough. So as I said before, you basically only need 2 frames to sell the trajectory of something and to have it still feel fast and impactful. So we have points that are sourcing on the edge of the sphere. So all I need to do is copy a line onto each one of those points, and then the frame before move that line out further away based on that normal. So when we play it back, we should get 2 frames. We'll get a frame of the tracer here and then a frame just as it makes contact with the sphere. So if we look at, say, our source points, so here's the sphere, and we're scattering some points on it, and those normals are pointing roughly in Z, if I can find any. There we go. So these are our impact points. So if we look at this through the camera, those impact points are spherical now. So in other words, the normals are pointing in all directions on positive Z. So I do need to try and repoint those normals so that it feels more like the gunfire is happening just behind the camera instead of from all the way around. So let me put down a point SOP, and I actually prefer the old point SOP, but let's give it a go. I'm still old school like that. So we got a point. Let's look at least 2 impacts here. So it's a bit tricky to work like this because we don't have very many points, but you can see there's 2 points. The normals are pointing in these directions, and the reason I want to edit the normals is because I can base the copied geometry direction based on those normals. So there's a million ways to repoint these normal directions, and I'm just going to give this a go. So basically, if I change the position, so say I move these points down here, plug that in as a second input, then we have the old position and we have the transform position, so I can point the normal in the direction of the transformed position. So we set the point SOP to normal, and there should be a preset here. The only thing I can see is second input's position, but that's not actually perfect. Let's have a look. So if I make that really long, you can see the direction of the normals passing through it. So I think I just subtract. So let's normalize this first of all, because we only need a direction for now, and we want to say input 1, so the new position, minus the old position, input 0, underscore P. So all we're doing there is the normal is based on taking this position minus this position. So that gives us the direction between the two. And you can see that's lining up perfectly. So maybe let me scatter some more so we can visualize here. Look at this through the camera. So that already feels better. If I take that off, you can see these are pointing, some of them are pointing kind of to the sky and to the ground. We want to make sure they're pointing out behind the camera, and then I can easily just come and scale this. So I can scale this, these 2 points down, move them up, bring them closer, take them further away, so we can have them feel like they're really coming from one enemy. So this is basically like us just tweaking this until we're happy with the general direction that we want the gunfire to come from. So I'll go with something like that for now. And I'll add this in here. So we basically just edited the normal of our source points. And I can write this back out. And there we go. So they're crazy long now because I didn't take away the scale. I've put a multiplier here of 83. Oh, and I have 10 times too many points. So let's try that again. There we go. So there's our new impact points, and the only difference is they have a normal. That should hopefully be useful to us. And there you can see better. They're kind of firing from somewhere here. So let's just use that and copy a line onto it. So I'm going to make a line, and we just need to point this in Z. And that's because when it gets copied onto points with a normal, it'll base the direction of that object based on the normal. So if this is pointing on, I'll show you. This is pretty basic stuff, but I think I'll just describe what I'm doing here. So you see there, I've copied a line onto those points, and immediately the line is matching exactly the direction of the normal, and that's because the line is oriented to Z. It's not because the environment or the camera or the direction we're working with is on Z. It's literally because a line on the Z axis will be transformed perfectly to a normal. So if I had the default settings, my line would just look like that. So as long as you orient an object on Z and then copy it on with something that has a normal, it will inherit that direction. So here we have essentially the final frame of the projectile before the impact effects happen. So you see we just need one more frame pretty much to sell that trajectory. So what else do I need? We can lengthen this up a bit. make sure we've got a bunch of points in there. And right now, before we do anything else, I'm going to add a new attribute on this line for a mask. So I just need to say a float attribute mask, which is based on $pt divided by $npt. So take the point and divide it by the amount of points in the line, and that'll give us a ramp from 0 to 1. Now, how do we get the second, or rather the first frame of the projectile? So all we need is for this point, the source point, to exist one frame before it actually gets created. So let's time shift this. So we have these points, and I'll say $f+1. So that point, this branch now exists one frame earlier than our real branch. And it exists for 2 frames. So I can base the position of this line based on age, because we used a pop. So let's see if I can do that just in here. So we have our translate on Z will give us, we'll move that copied object along the axis of the normal, not necessarily on the axis of Z. So we can base this on age. So if age is, let me think about this. So if age is low, let me use numbers first. So 0 is our point of contact, and the frame before would be, say, 2.2. So we actually want to subtract age, or let's try that. So 2.2 minus age. No, this, it's capital. So in theory this works, but I would be working with a sort of random value here, because my age needs to be divided by life. So what I'm actually going to do here is make another attribute on this point. Let's just call this pos for position, and we'll do age divided by life. So that should at least give us our value between 0 and 1. Let's have a look at the spreadsheet here. So pos. So we have, yep. So we have a value that's going from low to high. But we can round that to give us a value that's either 0 or 1. So let's say if we do round, so what we said was about, say, 3 minus pos. So I'm just trying to see if this is actually working or doing anything. Let's just make sure my attributes are coming through. So there's a point there. here's our line. So we want to say take pos. So there we can see it's going in the wrong direction. So we definitely want to subtract pos. So that's working fine. And then, like I said, if we round it, we should get 1 and 0. Not quite. So that's not quite giving me what I want, because I guess I'm still getting an offset of 1. I could also try dividing this. So I'm just messing around here to try and figure out how I'm going to get what I want. It's a pretty basic thing to set up, but I feel slightly like I might be overthinking this. This is working, so I'm getting a frame here, and this is offset by age divided by life. So that's, at the moment, that's 1 minus 0, because the age is something like 0.1 and it's being rounded. So that should be rounded to 1. And then the next frame, the age is probably over 0.5. So we round that 1 minus 0.6 or something will give us 0. So we have an offset and then 0 offset there. If I multiply that whole thing, it's giving me a greater offset on the frame before, because the second frame, it's being multiplied, it's 0 multiplied by 2. So no matter what, the second frame will always be the impact frame, and the frame before, we can choose how far we want that just by multiplying this. So that works. I just had I think I was struggling with overthinking it there for a bit. So there you can see we have 2 frames of projectiles. And that should be all we need. Let me go in here and add a color as well. So we have this mask attribute on the line. I can take actually this nice orangey color I've got down here. Based on mask. So we just want to make sure we've got a hot front end of our tracer, and then it can go dark or transparent out the back. So at this point I would also probably duplicate something for our alpha. Or we have, I do need a width as well, because we can just render this line. We don't really need to scatter points or put down a poly wire, nothing like that. So let's see, if I do CD don't think I need that. I just need an alpha based on color, and then our width can be based on the alpha as well, multiplied by something. We don't need to worry too much about that, and we can look at these values again when we're rendering. But here we just have an alpha, so that's cool. And then I'm also going to pop down a noise. So we'll revisit this when we start looking at the render setups, but the likelihood is we need a velocity attribute, and we can change that value unrealistically long. So the point is, if you add some noise to this line, just subtle, and then you make sure that motion blur is blurring this projectile quite a lot, then that noise kind of blends all into one thing that still feels like a line, but it feels like a more detailed version. Not to mention, if you look at a lot of reference of traces, you'll see they are quite noisy. So we just want to add a 3D noise to P, and then we can also plug in some, like the frame number, into offset so that it moves, just so that they never appear the same. And we can multiply that noise by that mask we have. So these lines already have a mask from the start to the end of the line, and we pretty much don't want the front end of the projectile to be so messed up. Okay, so here you can see I'm adding noise, but not to the front part. I can add a little bit to the front. And then this just needs to be much more subtle. So just something like that is enough, because when this is motion blurred, you should get an interesting level of detail out the back of this projectile. So there they are. And I'll just do a flipbook quickly using these merged with what we have down here. And in the next video we can carry on with the really fun stuff here and mess around with our particle sims. Oh, some of these are crazy noisy. But we can see these are working fine. So I'll probably mess around with the trajectory to make sure they feel like they're actually coming somewhat from behind camera instead of always from the left. And then obviously the noise is way too crazy at the moment. And you'll only rarely get the full effect of these once you render them, because I'll have that width attribute and the slightly transparent tail. They won't look as obviously just lines. But it's still a helpful visualizer here as we move on with the rest of the effects, just to see something flying into the shield before each impact. And I think at some point we'll come back and add some more of these hitting the ground and maybe the back wall before the shield actually appears. So that's a good start. I'll end this here and we'll come back in the next one and mess around with these particle sims. So I'll see you then.